Hi, my name is David Cook. Today we're going to discuss how to choose an intraocular lens. I'm mainly going to center on lenses chosen with formulas that are available for free, mainly on those that are in United States machines that come for free. I'll mainly discuss spheres, and these are the questions that I want to answer. What do you do if you have several formulas? How do you choose which formula to use? What if you have no formulas at all on your device? I was in Honduras and they handed me a sheet that said, here's the axial length from the patient, here's the K reading, here's the A constant, and here's your calculator, and figure out which lens we should use for the patient using the SRK2 formula. Is that the best thing to do? What if you have partial measurements? I was in Zimbabwe and I was entering the country. I had my A scan in my suitcase and I had a separate autokeratometer, autorefractor. They saw that unit, they confiscated it at the border, and I was only there about a week. They kept it most the whole time. So all I had was the A scan. What do you do if that's all you have? What do you do if you have no measurements? What if their eyes are very short or very long? And what if you don't have the proper lens constant for the formula that you're using? I'll try to answer all those questions today. At the very end, and so if you're only interested in these, you could run to the end of it. At the very end, I'll discuss real briefly, what do you do if you have eyes that have high astigmatism or eyes that are post-LASIK? Here we go. If you have partial biometry measurements, so you're entering a country and they take away one of your units, what do? There was a nice paper that came out in 2012 by a group from the United States Navy. They do humanitarian missions, and apparently they've run into the same problem because they published a paper that looked at this particular question, and they found that if you only have axial lengths, then the best thing to do, so you don't have a keratometer, you take this formula and you take 1.3 times the axial length and you add 75 to it, and you use that number instead of your K's. That works better than just guessing. What if you have only K's or you don't have any measurements? They found that there was no formula that worked for these. The best thing to use was just the mean intraocular lens power for that particular population. Well, how do you know that power? They published another formula, and this was also for humanitarian missions, and this was also out of the United States Navy. This particular author right here was on both papers, and this one came out a few years before. This was in 2009. They showed the average or the mean IOL power for several different populations. And if you look at it, it was about a 21.5 diopter lens. Now, for the Taiwan population, it was 20.0 because that population is a more myopic population. So a more myopic population is going to require a lower lens power. These A constants were about a 118.5. So if you have a lens that has a 119, you'll want to go up about a half diopter, so you would use about a 22.0 mean IOL power for your population. And then my friend in Zimbabwe, when he operates on men, he uses a 21.0 because he didn't have any equipment to measure. And when he operated on women, he used 1 diopter higher, 22.0. And the reason was he wanted he knew that the women did more near tasks, so he gave them a little bit higher IOL power. What do you do if you have several formulas? How do you know which one to use? There are several formulas available, and the 4 that are on most machines are listed here. There are 2 other formulas that are available for free. They're on the web. We'll talk about those in a minute. And then there are these 2 formulas that are available for purchase. And then there's the last one that I list here, the SRK2. I have one comment on the SRK2, and that's don't use it. It's not as good as the other formulas. So these 4 formulas are the main formulas that we'll talk about. The Huygens requires an anterior chamber depth, so it requires an extra reading. You may not have that, so you may be limited to the other three. The SRKT does not do well with steep corneas. The T2 might be a better option. Dr. Huygens in 1993 published this paper that showed there was a problem with the SRKT in steep corneas. This was finally resolved in 2010 by a group led by Richard Sheard. They developed the T2 formula, and that addresses the steep cornea problem. So back to the question, which formula is best? Dr. Aristodemo Petros, he and others, put out a paper that discussed this particular question. They used National Health Service data from England. So they had a lot of eyes. They had 8,000 eyes. They did not have anterior chamber depth in most of these eyes. So they only looked at 3 formulas. Now I have 4 formulas on here because they also went back later and added the T2 formula. This is an unpublished slide using the T2 formula. They gave it to me and I'm using it with their permission. There's a lot on this slide, so I'll go through it slowly. On the y-axis is the mean absolute error. And you'll see from this that the lower numbers are at the bottom, and that's where you want. If your formula is really accurate, the value would be 0. So you want the values low. The lower on this list that the line goes, the better that formula is. On the x-axis, we have short eyes on the left, 20 diopters, and long eyes on the right. Most formulas, if you look at eyes from about 21.5 millimeters to eyes that are 26 millimeters in length, so that's most eyes, most formulas are about the same for most eyes. Short eyes, you see a difference here. One formula, the Hoffer-Q, has a lower mean absolute error, so that's a better formula. And several papers have shown this as well. Long eyes, there's quite a spread. And you'll see that the blue and the green lines, the Hoffer-Q and the Holiday 1, do not do well in long eyes. The best one was the SRKT. It was statistically significant better for long eyes. Now at the really long eye length, there were only about 20 in this group. So you can't say much about these really long eyes. There was another group, mainly out of Baylor, that looked at the question about really long eyes and said, for eyes that are longer than 25, can we correct those by just adjusting the axial length? And they came up with different formulas to use for each of those lens formulas. I've looked at about 500 of these eyes, and in my data, the best one was the Holiday 1 adjuster, and it worked really quite well. So that's the only one I'm going to list in this paper. But you could look up any of the others if you're interested. The reference is at the bottom of the screen. Basically, the intraocular lens is determined by adjusting the axial length. You take the IOL master axial length. Well, you take 88% of the IOL master length. You add to it 2.9, and you use that as your new axial length and put it in the Holiday 1 formula. So, now is another question. What do you do if you have no access to any formula? Like in Honduras, where they handed me a calculator. You're way better off to look on the web. There are a couple formulas available for free on the web. This one is the T2 formula calculator. This is available at richardsheard.net for free. Another one, and that was out of England. This one is out of Australia. This is by Dr. Graham Barrett. It's the Universal 2 formula. It's about the same as the T2 if all you have is axial length and Ks, but it's better if you have lens thickness and white to white. We'll review what we've done. If you have several formulas, we discussed what formulas should you use. If you have no formula for your device, what do? You can look up some formulas. If you have partial measurements, there are some adjustments. If you have short eyes or long eyes, use different formulas. What do you do if you don't have the proper lens constant? So let's say you have measurements, you have formulas, but you don't know what the lens constant is. You could start with the A constant on the box. You have to be a little careful. A lot of the Alcon lenses were designed with the SRK2 formula, and so those lens constants aren't quite the same as for an SRKT. So you could go on the web and you could look at the ULIB website. This is run by Dr. Higas, and on it there are lens constants for all these formulas. They're designed for use with the IOL master, and they really are pretty good. What if you have, let's say you have measurements and you have the Holiday 1 formula, you'd like to use that, but you only have the A constant. You don't have the surgeon factor that you need. That's a different constant. You need the surgeon factor if you can use a Holiday 1. Where do you find that? Or how do you get that? Well, if you have an A constant, you can use this lens constant calculator, also on the ULIB website. It's a little different. It's a different web page, so I have the address here for you. You can put in the SRK A constant, the SRKT A constant, and it will give you the surgeon factor. You can then use that in your Holiday 1 formula. So the summary. If your eyes are shorter than 21.5 millimeters, use the Hoffer Q formula. If they're greater than 26 millimeters, use the SRKT or the Higas formula. If they're greater than 27 millimeters, adjust the axial length and use the Holiday 1 formula. Don't use the SRK2. Don't use the SRKT for steep corneas. If you have no measurements at all, use a mean IOL. Often that's at 21.5 diopters, using an A constant of 118.5. If you have no Ks, you could substitute a value using your axial length. If you have no formula and you want to look online, you can find 2 formulas that are both good. And lastly, this is not a summary, but if you've had an eye that's had prior LASIK or PRK or RK, you can go online to iolcalc.org. That's the website that's run by ASCRS, and on that website it gives good information as to how to adjust things to get a better result than you would have with the normal formula. If you have an eye with a lot of astigmatism and you'd like to include posterior corneal astigmatism, this is something we've not talked about today, but there is a website at pcacalculator.org that walks you through how to do this. More help is available on a wonderful website by Dr. Hill, and I've listed it here for you. I'm also very interested in intraocular lens calculations, and sometimes I can be helpful, sometimes not. If you'd like to email me with a specific question about choosing an intraocular lens, I've listed my email address here for you as well. Thank you very much for watching this course. I hope it's been helpful. Good luck in choosing intraocular lenses, and I hope you find the rest of the course helpful as well.